Okay, we got two simple concepts to deal with today. They are involved in drawing pictures. If you get the picture drawn, or I should say when you get the picture drawn accurately, then it just becomes a right triangle problem. Two phrases. Angle of elevation and angle of depression. Both of these are ways of measuring angles in, I guess, real-world problems or real-world scenarios. Okay. There's one main thing to remember, and that is both of these are measured from horizontal. So we'll put a cloud around that. Arrows pointing at it. Put some stars here. It's kind of important that you remember that. So let's look at a scenario. Two people standing on roofs. One person is higher than the other. The blue guy's name is Gerald. Nice. With a G? I don't know how to spell Gerald. We're going to make it G. I think this is right. Gerald?
Yeah.
All right. And the red guy's name is? Could be a woman too.
Anthony.
Anthony? Okay. Who's higher off the ground?
Anthony.
Okay. Now, the reason I ask that obvious question is when you're done with the problem, you may want to consider your answer. Okay, no measurements here, so you would have to be given some information. Like, for instance, you might know that it's 100 yards. The buildings are 100 yards apart. Excuse me. And there's two angles we're going to deal with here. One is the angle from Gerald up to Anthony, and the other one is the angle from Anthony down to Gerald. So we're going to start with Gerald first. Gerald has an angle of elevation. We'll call it theta. Okay. Have we done any Greek letters before? Beautiful. Okay, so that's a theta. That's an angle of elevation. How do you know it's an angle of elevation? Because if you draw a horizontal from his eye, you're going to go from horizontal up. Because it's an elevation. If we go over to Anthony, Anthony has an angle of depression. So let's suppose Gerald can measure angles. He just happens to have a handy-dandy angle measurer in his pocket. And he knows that the angle of elevation is 37 degrees from his eye up to Anthony. How big is Anthony's angle of depression? John?
37 degrees.
Why?
Because it's with alternate interior angle.
Beautiful. These are both horizontal. And therefore they must be level because all horizontal lines are level. And as Sean mentioned, those are alternate interior angles. So this is also 37 degrees. We'd like to know how far is it from Gerald to Anthony? What's that? No, I just didn't hear what you said.
I said 100, right?
Horizontally, yes, but we'd like to know how long that pink segment is. So I need a variable, I'll call this x. And we're going to calculate x. Notice I don't have a right triangle yet, so I'm going to make a right triangle at some point in time. But you have two different triangles to work with. You can either work with the triangle from Gerald, or you can work with the triangle from Anthony. Which one do you prefer? Gerald. All right, so we're going to make a triangle from Gerald to Anthony. It's got to be a right triangle because this right triangle trig doesn't work unless you have a right triangle. my picture's off a little bit, but let's assume that Anthony is standing over on the, let me fix my picture here. Let's assume that Anthony is standing over on the edge of the building. Okay, so that's 100 yards, which would make this 100. And I want to solve for x. Which function? Sine, cosine, or tangent? Cosine? Why? Come here. 100 is the adjacent side, x is the hypotenuse. Okay, so if you can get the picture drawn, then everything else is just what we've done already. This becomes a straightforward trig calculation. Cosine of 37 degrees is equal to 100 over x or x over 100? Okay, solve that, please. Can somebody confirm 125.2? What are the units? Yards, good. Is that answer reasonable? Before we even started the calculation, what did we know about x? Longer than 100, very good. Now, we could also ask a couple questions like, how much farther off the ground is Anthony than Gerald? Well, that would mean I'd have to solve for this distance, which I'd call maybe y. If you're going to use a variable in your calculation, make sure your variable is listed in your picture so that if you're calculating x, I know what x is. Question?
What does y represent?
Y would represent how much higher off the ground Anthony is than Gerald. Because what we don't know right now is how far off the ground Gerald is. Okay. If we did know that, then we could calculate exactly how high Anthony is off the ground. Okay? Now, what's going to happen is you're going to get the angle of elevation and angle of depression confused because a lot of the problems are word problems without a picture. Very seldomly, if ever, do we talk about this angle down here. But let's, just for giggles. How big is that angle? Augie? 53, why?
Because it's adjacent to the 37 and it's complementary.
Good. That's one reason. Why else is that 53 degrees? Okay, good.
You subtract 37 from 90
Yeah.
and 180.
Yep, looking at this triangle, these two angles are complementary. Okay, so we could do calculations with the 53 degrees, but that's usually not an angle that's discussed in problems. That's not an angle of elevation. That's not an angle of depression. The reason it's not an angle of elevation is because, as it says in this slide, it's got to go from the horizontal. This is an angle measured from the vertical upward. Doesn't work for us. Okay, does that make sense? So that allows us to do problems like this where we want to measure the height of the tree. Okay, we did a flagpole example. This one will pretend you're laying in the grass with your eyeball sitting in the grass. Let's do alpha now. Is alpha an angle of elevation or an angle of depression?
Elevation.
Elevation, correct, because we're going from the horizontal ground upwards. Now, if there's a bird sitting in the tree, looks like an airplane. Okay, there's a bird, good. The bird also has an angle of alpha there. It's angle of depression. Okay, again, not this angle here. And we're going to make some assumptions. We're going to assume the trees are perpendicular to the ground. We're going to assume the buildings are perpendicular. Anything that's a structure will be perpendicular unless otherwise noted. Okay? Seem fairly simple? Yes or no? Okay, good. It will get a little bit more complicated, but if you can get that right triangle drawn, then it just becomes a matter of doing your right triangle trig. Question?
So if you find the angle of the elevation, is it the same as the angle of the depression? So you'll have to find one.
The angle of elevation for you laying in the grass over here is the same as the angle of depression for the bird over here.
So if it's asking for both, you just have to find one.
Right. Yeah, so a problem like this, you would say, you're laying in the grass 150 feet away from a tree, and you look up and you just happen, again, this gets a little, you just happen to know this tree is 57 feet tall. By the way, that's feet, right? This is inches. Okay, just want to make sure we're all on the same page there. You just happen to know that tree is 57 feet tall. I don't know how you would know that, but the question is, what's the angle of depression from the bird to you laying in the grass? Okay. You could set up this triangle and solve that one, or just solve this one, realizing that this angle and that angle are the same. So go ahead, solve that. Tell me what alpha is. Sine, cosine, or tangent? Tangent, very good. Hmm? 20.8. Caitlin, what equation did you set up?
Tangent of alpha equals 57 over
Okay. Then what?
then I did 57 divided by 150.
Then what?
That's how I find that.
Okay. Patrick?
Inverse tan.
Good. Whoops. Take the inverse tan of both sides. This cancels. We're left with alpha being, what'd you say, 28.1, 20.1?
20.8
20, that was close. 20.8 what?
feet.
No,
Degrees.
degrees, it's an angle. Okay. So the angle that you're looking up to the tree is 20.8. The angle that the bird is looking down at you is 20.8. The angle between this and how big is that angle? Or can you easily find that angle? Yeah, okay. Was it 69.2, right? All right, good. And again, the assumption here is that the tree is perpendicular to the ground. All righty. Gesundheit. Now, eventually where we're going with this is we'll have a couple more complicated problems. We'll figure out how to measure the heights of things we can't measure. Like, let's say, for instance, I don't know how to, I can't figure out the height of the tree. I can't measure the height of the tree. I can't measure the height of the flagpole. There's a way we can calculate the tree just using angles. We'll talk about that. And then eventually we're going to work towards solving triangles that aren't right triangles. There are methods that we can use to find angles and sides in triangles that aren't right triangles. But that's a ways away. In fact, we'll get to that stuff after the final exam. So we'll stop after this angle of elevation and depression. Okay, questions? We're good? Day 7.
You want us to turn in day 6?
Oh yeah, sorry, I forgot. Turn in day 6, please.